With 2D NAND reaching its end, we were all genuinely worried, how am I going to continue to extend Moore's law? And along comes 3D that opens up everything in front of us. In 2D NAND, the bigger issues are with respect to printing finer and finer lines. There is a limit to how fine a line you can print, and that was the big issue which stopped the scaling of 2D NAND. In 3D NAND, the problems are quite different. Because you are building more layers one above the other, just like you build with the skyscrapers, where do I put the crane? How do I build the next layer above it? How do I get material all the way to the bottom of a hole? How do I build the elevator that will take material all the way back up to the top? Those kinds of issues are much more important to 3D. 3D NAND, of course, offers the additional advantage of being lower power, higher reliability, and higher performance as we increase the integration. SanDisk has a unique advantage in that it has a very large manufacturing presence in fabs. We have a very large presence in assembly and test that goes with it. We have a very strong interaction with our customer use models.
In addition to making our current products even better and allowing us to keep up with the demands of users and the expectations in both capacity and performance, we also see 3D NAND enabling new markets, from automotive to connected home and to cloud computing in the way that we interact today with digital devices.
You will see more and more cases where most of the rotating media, meaning the magnetic drives that hold these bits, will all be replaced by solid-state drives that contain 3D NAND.